Okay, so today what we're going to be doing is simplifying radicals, and that's different than what we did the other day. The other day we just threw the radicals or the square roots inside the calculator and got numbers for the values, but today what we're going to do is we're going to simplify them like we simplify fractions. So we might see something like 2/4, and we reduce that or simplify that to 1/2. We're going to do the same thing with square root signs. In order to simplify square roots, you need to know your perfect squares. Now, perfect square monomials is just the product of two equal factors. The product of two equal factors, which means I'm going to multiply the same thing by itself. Okay? And that's going to give me a perfect square. So x squared is a perfect square because x times x is equal to x squared. That's why it's a perfect square monomial. N to the sixth is n to the third times n to the third. Because remember, when we're multiplying, we add the exponents. What you need to be aware of is any variable with an even exponent. Any variable with an even exponent is a perfect square. We've already talked about our perfect square numbers both earlier in the year and in the last chapter. So we're going to be coming back to that on the next page. Okay, so there's a couple different rules that we're going to use today, two of them specifically. If we have a product underneath the radical sign, that would be something like 4 times 5. If I had something like 4 times 5 underneath the square root sign, what I'm allowed to do is break it apart into two different radicals and multiply those radicals together. So if I had something like 4 times 5 underneath the square root sign, I can say the square root of 20 is equal to the square root of 4 times the square root of 5. 4 times 5 is 20, and I'm allowed to break it apart into two different radicals. I can use the exact same rule for division. When I have a fraction underneath the square root sign, I can break it apart and give the radical to both the numerator and the denominator. So if I had something like the square root of 3 over 4, then I can break it apart and say that's the square root of 3 over the square root of 4. And those are the two rules that we're going to use today to simplify radicals. Okay, so the first couple examples are easy to simplify. What I want you to notice is we're going to simplify the square root of 16n squared. You should automatically have in your head that the square root of 16 is a perfect square. And because that variable has an even exponent, he's also a perfect square. So right off the bat, I can take the square root of 16n squared. The square root of 16 is 4. And the square root of n squared is n. Remember, we talked about inverse operations. When we square a square root, we get that number back. Or we can say, because n times n is n squared, the square root of n squared is just n. Okay, the square root of 25 over 49. With our division rule, we can break that apart and say that's the square root of 25 over the square root of 49. And then we can take those square roots individually. The square root of 25 is 5. And the square root of 49 is 7. Now the tough thing about division is that we can either break it apart into two different radicals, like I did in the second example, or I also have the option of dividing the numbers underneath the square root sign if they're easily divisible. So what I can do is I can say, all right, well, I know that 36 divided by 4 is 9, and a over a to the third is a squared in the denominator. There's 1 in the numerator, 3 in the denominator, so I can reduce that and break that apart into two different radicals. Now I take the square root of 9, which is 3, and the square root of a squared, which is a. So the rule for multiplication and division, if I have a product or quotient underneath the square root sign, then I can break it apart into two different radicals. However, You cannot do that with addition underneath the square root sign. If there's addition underneath the square root sign, you can't break it apart into two different radicals. So what I'm going to do is I'm going to show you an example how it doesn't work. I want to know if the square root of 9 plus 25 is the same thing as the square root of 9 plus the square root of 25. So I'm going to add the 9 and 25 together, and I'll get the square root of 34. And if I were to put the square root of 34 in my calculator, I'm going to get approximately 5.8. Now, if I do the radicals separately, the square root of 9 is 3, and the square root of 25 is 5, and 3 plus 5 is 8. And these things are clearly not the same. So again, you cannot break apart the radicals if there's a plus or a minus sign underneath the square root. Okay, now we'll take a look at the next page where we're actually going to do some more simplifying. Now, in order to simplify radicals, you need to be very, very, very comfortable with your perfect squares. 1 times 1 is 1, so 1 is a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. And you keep going like that until you get to at least 15. So 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, and 15 times 15. Most of the time you won't see anything higher than 144, 12 times 12, but occasionally you're going to see the 14 times 14, 15 times 15, 16 times 16. Remember, you can always use your graphing calculator to check the square root of those numbers if you're not sure, or create them. Okay, so when we're simplifying radicals, what we're going to do is we're going to look for any perfect square factors underneath the square root sign. So when I did the square root of 20 on the first page, 20 had a factor that is one of those perfect squares, which was 4. Secondly, we can't have a square root in the denominator. We cannot have a square root in the denominator of a fraction. That's not simplified. And we can't have a fraction underneath the radical. That's not simplified. Okay, so let's take a look at some examples. Number 1, the square root of 25y squared. What you should notice is 25 is already a perfect square, and so is y squared, because y squared has an even exponent, which makes him perfect. So right off the bat, I can take the square root. The square root of 25 is 5, and the square root of y squared is y. And you're done. Now what I'm going to do is I'm going to skip example 2. I'm going to go down to example 3 and do the first column, at least the first few problems in the first column. Okay, example 3. 32 is not a perfect square. It's not on our list. So what you need to say to yourself is, you can't put these in the calculator because we're simplifying the square roots. What you need to say to yourself is, which one of these perfect squares goes into 32? And I need the biggest number that goes into 32. So you might say to yourself, okay, well 4 goes into 32, but 4 is not the biggest perfect square. The biggest perfect square that goes into 32 is 16. So 32 is really the same thing as 16 times 2. So what I'm going to do is I'm going to break it into 2 different radicals and put 16 in one and 2 in the other. And you can put a dot in between them for multiplication, but we usually don't do that. Now, what we're going to do is we're going to call this the good house. And we're going to call this one the bad house. And the reason we do that is because the good guy is the perfect square. And when you're good, you get to come out of the house. Right? If you're good, you can come outside, but if you're bad, you have to stay in the house. You're grounded. Right? So the good guy comes out of the house, so the square root of 16 is 4. The bad guy stays in the house, the square root of 2. So 4 square root of 2 is the same thing as radical 32. You can put the square root of 32 in your calculator and get the same number as 4 radical 2. Okay, now let's try it number 5 with just variables. X to the third is not an even exponent, which means that he's not a perfect square. But there is a perfect square factor. X squared times x is the same thing as x to the third. So what I'm going to do is I'm going to break it apart into 2 different radicals, put the good guy, the perfect square, in the good house, the bad guy, the one that's not the perfect square, in the bad house. The good guy gets to come out of the house, so the square root of x squared is x, and the bad guy stays in the house, square root of x. Okay, let's take a look at number 7, because there's a lot going on with number 7. First of all, I want you to notice that 50 x to the third y squared is not a perfect square, because 50 is not and x to the third isn't. So what I'm going to do is I'm going to do my good house, bad house, and I'm going to ask myself, which number on that list of perfect squares goes into 50? And I'll find that it's 25, and 25 times 2 is 50. So 2 goes in the bad house because he's not a perfect square. 25 goes in the good house because he is. X to the third is not perfect because he has an odd exponent. However, if I just drop the exponent down by 1, I get a perfect square. But I have an x to the third, not an x squared, so the leftover x has to go in the bad house. Y squared is a perfect square because he has an even exponent, so he's going to go in the good house. Now remember, the good guys get to come out of the house, so they're going to come out. The square root of 25 is 5, the square root of x squared is x, and the square root of y squared is y, and you're left with radical 2x. Okay, now what I'm going to do is I want you to pause the video. I want you to work on number 2, 4, 6, and 8. When I come back to the video, I'll have those complete. Okay, so in number 2, hopefully you notice that all of those values are perfect squares. 64 is on our list of perfect squares. If we take the square root of 0.64, we get 0.8. When you're taking the square root of a variable, you want to cut the exponent in half. Number 4, you should get 5y radical 3. Number 6, you should get y to the third radical y. Now number 8 is a little bit different because we've got a number out or a variable out in front. That variable out in front just means multiply. Like I could put multiplication signs in between here. I don't usually, you won't see it written like that, but just so you understand, it's multiplication. So it's like we have negative 1 times 4, which is negative 4. M to the first times m to the fourth is m to the fifth, because when we multiply, we keep the base and add the exponents. Okay, so now we're going to take a look at number 9. Number 9 is division, which has slightly different rules. Excuse me. Now, notice right off the bat that both 8 and 50 have their own radicals. So what we can do is we can say, all right, well, I can put 80 divided by 50 in my, or 8 divided by 50 in my calculator, because they divide, and then I'll reduce them. So when I put 80 over 50 or 8 over 50 in my calculator, I get 4 over 25. And then when I do x to the third divided by x, I get x squared, and that x squared is going to go with the 4. Now, I give the radical to both numerator and denominator. And then these guys happen to all be perfect squares. 4x squared, the square root of 4x squared is 2x, and the square root of 25 is 5. Okay, now I'm going to go over to number 10. Number 10 is the square root of 98. So what you're saying to yourself is, what's the perfect square that goes into 98 on that list of perfect squares? So hopefully you'll know that that's 49 times 2. Then you take the square root of 49, which is 7. Keep the bad guy in the house, 7 radical 2. Okay, 11 is another division question. Now 11, I can't divide these values nicely, so right off the bat, I'm just going to do a radical for the numerator and a radical for the denominator. And the only reason I did this one slightly different than number 9 is because I can't divide those things. They don't divide nice. Now the numerator is not a perfect square because I don't have an even exponent. So I'm going to do good house, bad house. 25 is a perfect square. And y squared is a perfect square with a y left over. Then in the denominator, I do have a perfect square. The square root of z squared is just z. So the square root of 25y squared is 5y. We leave the radical y in the house over z. Okay, last one. 16, square root of 16b to the fifth. So what I want to do is notice that they're not all perfect squares, so I'm going to have to do good house, bad house. 16 is on my list of numbers. 16 is a perfect square, so he's going to go in the good house. B to the fifth, I have to drop the exponent down by 1 to make them even, and the leftover b goes in the house. The good guys get to come out of the house, so the square root of 16 is 4. The square root of b to the fourth is b squared. The bad guy stays in the house. That's it. Now remember, when you're doing your homework, no decimals. You should not have any decimals, unless it was something like number 2, where we had the square root of 0.64, which was the square root of 0.8. I do not want you putting something like the square root of 98 in your calculator and giving me a decimal. That's not how we simplify radicals. You do good house, bad house for each of them, unless the whole thing is a perfect square.